All right, question number 18. We want to answer the four questions presented. It says determine whether the following statements are true, give an explanation or counterexample. It says the function x times sine of x can be differentiated without using the chain rule. And I would say yes, we just have two functions and we're going to be using the product rule. And so out of the answer choices, we are looking at the statement is false, and it says can be differentiated without using the chain rule, and I think it can be, so we're looking for a true statement. Since x times sine of x is the product of two functions, the derivative must be computed using the chain rule. Now, product of two functions would be product rule, so not B. Looking at C, statement is true if x times sine of x is represented as the product of two functions, then the derivative can be calculated using the product and power rule. So yes. All right. B says the function e raised to the power square root of x plus 1 must be differentiated using the chain rule. And I would say yes, you cannot separate that. Usually you can write powers. For example, if I had x2 plus 5x, according to the property, you can separate this. And you can do like a product rule using a power rule, but you can't separate this because it's in a grouping symbol. So you would have to use a chain rule for sure. So we're looking for a true statement that will look at C or D. The statement is true. The exponent in the e to the square root of x plus 1 prevents it from being written in expanded form. Therefore, must be differentiated using the chain rule. Looks good. And then D says since E can be written as a composition of functions, and that's not writing it as a composition of functions. That's using substitution, which would still cause us to use a chain rule. So I think the explanation here is incorrect, but if you did use the substitution, that's just, again, using the chain rule. This is not a composition of functions, so just be careful. They said, what did I pick? Oh, I picked D. C is the correct answer. When I clicked that one, it chose D, but C is the one that we want. And then C says the derivative of a product is not the product of the derivatives, but the derivative of a composition is a product of derivatives. And the way that reads is weird. So let me look at what we're saying. The derivative of a product. So let's say we have f of x times g of x. When we do this derivative, we get 1 d2 plus 2 d1. Okay, so this is not the same as just taking the derivative of each of them and multiplying them. We actually end up with a sum. So it says the derivative of a product is not the product of derivatives. That's a true statement. It's not the product of the two derivatives. So we got a sum here. But the derivative of a composition is a product of derivatives. So composition, let's say we had f of g of x. Okay, so when we do this, we get the derivative of f evaluated if this g of x and then times g prime of x. So we do end up with a product here, f and g being multiplied, but it's, you got to make sure it's being evaluated at g of x. So that's the only difference. But it says, but the derivative of a composition is a product. Okay, it is a product multiplication of those two derivatives. Okay, so we'll say that is a true statement. Statement is true. The product rule by the product rule, the derivative of a product is a sum, and by the chain rule, the derivative of a composition, the derivative of a composition is a composition of functions. And that would not be true because we're not talking about a chain rule. So D, statement is true, the derivative of the product, and this is just the notation in one such text, while the derivative of a composition is this. And they just don't have the arguments plugged in, but that would be true. And then D, it says the derivative of a composition is equal to just the derivative of P evaluated at X and the derivative of Q evaluated at X. And that would not be a true statement. And so we want to give a counter example. If you use A, it would prove that that is the same. Okay, so let's just kind of go through them. You're looking at P of Q of X is equal to P prime Q prime. Okay, so if we did P of X is 2X and we plugged in 3X, we would be looking at 2 times 3X composition, which is 6X. The derivative of this would just be 6. And if I did the derivative of PX, I would just get 2, which is 2X. The derivative of Q would be just 3, and then 2 times 3 gives us 6. So those would be equal in this case. So that's not what we're looking for. That says true, and that just gives you the same thing. So no, statement is true because P Q of X can be written as P times Q of X. That's not the same. D, statement is false. So let's look at D. If we look at P of X, X squared, and Q of X is equal to X to the third, P of Q of X would be X to the third plugged into the X squared, which will give us power to a power you multiply, X to the 6th. Derivative of X to the 6th will give us 6X to the 5th. Now if we multiply the two, we have X squared and X to the third. The derivative of Px would be 2X. The derivative of X to the third would be 3X squared. If you multiply these two, 2 times 3 gives us 6, X to the third. And we can see that these two are not equal. So D is the one that gives the counter example.